Let's take our first look at exponential and logarithmic functions. At the top, I've written the general form of an exponential function, where below, here's the general form of a logarithmic function. These are two different functions. The way they're written, we can see graphs in the form given on the left here. The red graph, the one in the upper left-hand quadrant, is a graph of y is equal to 10 to the power of x. Now this isn't the first time that we've seen an exponent, but it is the first time that we see our unknown, the value for x, in the exponent position. The graphs we've looked at up to date look like this. Y is equal to x squared, for example, where our unknown is the base and our exponent is a known value. So we've seen the base vary and asked what is the value for y as we vary x. What we've not seen before is y is equal to 10 to the power of x, for example, where the exponent varies. We ask the same question as x varies, what is the value of y? But the function looks very different. So what's the blue graph down here? Well, if I take y is equal to 10 to the power of x and I reflect it across this line, y is equal to x, I get the graph in blue in the lower right-hand quadrant. The equation for this graph is y is equal to the logarithm of x to the base 10. Or we can simply write this as y is equal to the logarithm of x. What this means is that y is equal to b to the x and y is equal to the logarithm of x to the base b aren't the same function, but they're clearly related. Notice that in both instances, we're told that b must be a value greater than 0. We can't evaluate the functions if b is less than 0, and b cannot be equal to 1. So while we are interested in looking at these two functions separately, we are going to spend most of our time looking at how we convert exponential functions to the same logarithmic function. In this case, where our two functions are not equivalent, that's less helpful to us. We want to be able to write y is equal to 10 to the power of x in its logarithmic form. Here's what we mean by that. So on the left here in red, I have the graph y is equal to 10 to the power of x. The graph on the right-hand side, the blue one, is identical. This is the graph of x is equal to the logarithm of y to the base 10. So in this case, we have the same function written in two different ways. On the left, it's written in exponential form, and the same function on the right is written in logarithmic form. So these two functions are equivalent. What we learn from this is that the logarithm is an exponent. Logarithms are the inverse of the exponential function. If we have x and we want to solve for y, well, then we can use the exponential version. Whereas if we know y and we'd like to solve for x, we can convert to logarithmic form to do so. That's one use of these two functions. How do we read these expressions? Well, we can say that the exponent x is the logarithm of the number y to the base b. Or alternately, x is the power, so the answer here, x is the power to which the base b must be raised to equal the number y. We can read that from the logarithmic form as well. X is the power to which the base b must be raised to give the number y. We'll put some numbers in place of these variables, and that should make it a little bit easier. Before we get too much further, let's do a quick review of how exponents work. So we're going to evaluate y is equal to 4 to the power of x for 3 values of x, and we'll practice doing this without our calculators. So in the first example, we have y is equal to 4 to the power of 2. 4 squared is just 16. So if x is equal to 2, y is equal to 16. In the second case, we're told that x is equal to negative 2, so y is equal to 4 to the power of negative 2. What do negative exponents ask us to do? They ask us to take the reciprocal of the base. So 4 to the power of negative 2 can be written as 1 over 4 to the power of positive 2, or 1 over 16. Here we have y is equal to 4 to the power of 3 over 2. Remember that the denominator tells us the order of the radical. So here we're being asked to take the square root of 4 and then raise the answer to the power of 3. Recall that you could also have taken the square root of 4 raised to the power of 3. The square root of 4 is 2, and 2 to the power of 3 is 8. So 4 to the power of 3 over 2 is equal to 8. Now we're ready to look at exponential and logarithmic forms.